So we want to write this equation at the top here in our usual form of a circle. The first thing is, how do we know this is the equation of a circle? Well, one thing to look out for is if you've got an equation that involves a quadratic in x and a quadratic in y, then this is probably a circle. So we're going to look to try to get it into our form of a circle to confirm this. We're going to add the constants to both sides. So we get x squared minus 16x plus y squared plus 8y is equal to negative 3, adding 2, taking off 5. Now we're going to complete the square in x and complete the square in y. So here we get x, and we halve this coefficient, minus 8 squared, but then this would have a constant term of 64, and there's no constant term here, so we take off 64. Then we do the same for y. We get y, half the coefficient of y, plus 4 squared minus 16, that's equal to minus 3. So minus 64 minus 16 is minus 80, and we're going to add 80 to both sides then. So we get x minus 8 squared plus y plus 4 squared is equal to 77. So here we have a circle of centre 8 minus 4 and radius square root of 77. Little subsection on circles, we're going to look at some circle theorems. So say this circle has a centre point here, we can then draw up a diameter through it, poorly drawn, but any triangle now that starts at the end point of the diameter and meets the circumference of the circle will be right angled. We can do this either way too. Okay, so that's the circle theorem 1. The specification we want you to know, especially helpful. All these probably most useful for geometry problems, hence why the specifications mix them in with the equation of a circle, because you might have some lines passing through circles and you might have to find some points, so these can be useful. If we have a radius, terribly drawn one at that, this always meets a tangent to a line at 90 degrees, so that's the next one they wanted you to know. And finally, if you have a chord, okay, which is a line from one point on the circumference to another that doesn't pass through the centre, then and remains entirely in the circle, of course, then if you find the radial line which meets it at 90 degrees, this point will be the midpoint of the chord, right? So in other words, a radius meeting a chord at 90 degrees bisects the chord, okay? So that's another thing you want to remember. That's it on circles. In the next A-level maths video, we're going to look at converting between Cartesian forms of equations and parameterized forms. So I think I said that wrong, but anyway, hopefully you know. I'll explain in the next video. Essentially, instead of writing y is equal to f of x, we can write y as some function of t, and that's supposed to be a g, and x is some function of t, and we can compare the relationship between x and y that way. Okay, so you got that to look forward to in the next video. If you didn't see the last video on the equation of a circle, be sure to check that out. And yeah, feel free to go through the whole A-level maths playlist in your own time. Thanks for watching. If you did enjoy, please like and subscribe, and I hope to see you in the next one.